Today we're going to take a look at section 2.1, which is symbols and terminology. And as we take a look at this, what I want to sort of maybe warn you, I guess, a little bit, is that the things that you've thought of as math all the way along are going to look different, right? I told you that when we were doing the syllabus, is that there are aspects of mathematics that you haven't encountered, and this section's probably a good start to being one of those areas. So we're going to take a look at, in this section, is a little bit, this whole chapter is set theory, okay? So for some terminology first, a set is simply a collection of objects. Those objects could be physical objects, right? Like your textbooks, like the ones you actually have books for. And it could be digital objects. It could be like the contacts in your phone, or your friends. So they don't have to actually be objects at all. The elements are the items or objects that belong to the set. So if we're talking about your textbooks, each individual book is an element of the set, my textbooks. Each individual name in your phone is an element of the set, contacts people in my phone. There are three different types of notations or ways of describing, showing sets. The first one is word descriptions. And so it's literally, a description. It lists it out in word form. So I'm going to give you an example of one so that you can see the difference that each of them would be if we were showing the same set in all these different forms. So we're going to describe, the first one is going to say all whole numbers less than 7. That would be a word description or a verbal description. I'm going to skip over the set builder and go down to listing second. The listing method is simply a list of those things that we just described. So in this case, and we'll talk more about our number systems in a minute on the next page, but whole numbers are positives. Okay, they're the numbers you first start learning to count with children, but whole numbers include the number 0 as well. So we would actually have 0, 1, 2, 3, 4, 5, and 6. 7 is not less than 7, it's equal to, so we wouldn't include it. And you see these inside of curly braces. Sometimes the curly braces inside of MyMathLab are already there. You don't need to actually put them. They just have you fill in the blank. That's usually how it is. So just be aware of that. If you accidentally put them in and you aren't supposed to put them in, MyMathLab will tell you got the question wrong. So just pay attention to notation. Sometimes it's silly little things like that catch us. All right, we're going to go back up now to set builder notation. Set builder notation is perhaps the most awkward to write down, but it has things that it's really good and useful for. This one's not a very good example of that, okay? So we'll see some that are better examples for why we would use this than this example. But it starts out with those same curly braces. And typically it uses some kind of a variable, and often that variable is x. So I'm going to write down an x. You can write down a different letter if you'd like. And then it has a vertical bar. Some books or some notations will actually have like a colon there instead, but our book uses a vertical bar. And then it's going to describe these things that are coming after it. So one of the things is that it says it's a whole number, right? We have to have specifically whole numbers, like we're not talking about the number 1.5, right? Okay. The other thing is it has to specify that it's numbers that are less than 7. It has to have both of those details in the description. And so the way that we actually list that is we usually list the fact that it's less than 7 first. So x is less than 7. That's pretty standard notation you're probably familiar with. The next one's not, and so I'm going to write down what it is, and then we're going to talk more about it later, okay? So there will be a comma, and it'll be one of two things. Let me write it out one way, and then we'll write out the less common way next, the less familiar way next. And so the first one that's most comfortable will be just to say that x is a whole number. And we will come back to this and fill in the remaining space right here after we have a little bit more notation to be able to show you how you're actually going to see it written more frequently. Okay, so for now, as you're looking at this set builder notation, it just looks a little clunky, doesn't it? It doesn't look like it has a whole lot of value to it in and of itself, because this set's not a very good description or reason for having this kind of a notation. So hold tight to that thought. We will talk more about that later. We also have something called the empty set or the null set. So the empty set or null set has two different notations that we see used. One is a 0 with a slash through it. So if you are in the habit of writing your zeros with a slash through them already, you need to stop, because this notation is not the number 0. This notation is an empty set. The other notation, and this is the most common one, but the other notation is to actually write curly braces and literally not put anything inside of them. Right? It's a set with nothing inside of it. So that kind of makes sense, because that's what a null set is. It's a set that contains no elements. Right? So imagine if you went and you bought a brand new phone. What are the contacts in the phone? Well, there's nothing in there yet. It's empty. Right? I can also describe for you sets for which this would be the case. So I'm going to give you an example, and I'm going to have you write one down for you. So don't write down my example. Hold tight, because my example may not actually fit with you. If you live on campus, it probably does. But here's my example. My example is, infants living in my home. There aren't any, right? There aren't any. You saw my picture. None of them were babies, right? None of them are babies anymore. And so there have been different points where I've actually written down an example here and said teenagers living in my home. I got 3 of those right now, and 4 when the older one comes home from college, because she's not quite 20 just yet. So that doesn't work anymore. So write down for yourself an example of a null set for you, okay? Something that doesn't fit. Something for which there's an empty category. Okay, everybody have one of those written down? All right, cool. Now I want to make note again about this notation. What I want you to see is not happening here is the 0 with the slash through it being inside of the curly braces. That's not the same thing, okay? So you can't merge the two notations together. It's one or the other. You can't use both of them at the same time. Cool? Okay, let's take a look at the next one. All right, so this one actually says we're going to list the elements in each set. It says use set notation. This should say set builder notation. Set notation simply means it has curly braces. So both of the descriptions we had before for the set builder notation and the listing method were set notations, because they both used curly braces. So set builder notation. And then we're going to use the listing method as well to describe the set. So our first one is the set of whole numbers greater than 8 and less than 18. And I'm going to go with the one that's most comfortable for us to work with first, which is the listing method. So the listing method means that we're going to start, and you don't have to start with the smallest, I guess, but usually going from smallest to largest is the most sort of natural. What's the smallest number that should be in this curly brace? 9, because it has to be greater than 8. So 9, and then 10, 11. How far am I going to go? To 17. All right. Common errors is for students to forget the less than or the less than or equal to kind of things and to accidentally include something or not include something they should. MyMathLab gives you multiple times to do a particular problem. I believe the number's 5 for the most part. So if you did it wrong, you can try it again. So pay attention to your notations if you're trying things again, especially if you're like, I thought I had it right. Like I thought I was right on the mark on this one, right? Well, check the notations. Check that you used commas and not an accidentally hit a period between it or something like that. So there's some common things that you can check. All right, set builder notation then. Starts out with the curly brace. And it always has the variable, I'm going to continue to use x in this bar. And we read this as x such that. And there's 2 things that have to be addressed. One thing that has to be addressed is the less than or equal to kind of notations, right? So I'm going to write this with 8 at the beginning and 18 at the end and x in the middle. And since it said greater than 8, this is the notation I want because it means that 8 is smaller. And then it has to be less than 18, so it would look like that. So we need that piece. The other piece that we have to include is that it's whole numbers. Again, we're not talking about the number 10.5, right? So we have to say x is a whole number. And again, I'm going to come back to this in a moment and give you a little bit more of a concise way of doing this, for which you can start to feel like, oh, that set notation is actually shorthand, which is what it's supposed to be, that set builder notation. Okay, number two. Number two actually kind of looks like a listing method already, right? So what do you think it means if it's asking you to write this in the listing method? Yeah, complete it. Fill it in, right? The dot, dot, dot's just going to be filled in. So we're going to start with our curly brace. We have our 2, 4, and 6. And then we're going to fill it in. Now, again, inside of my math lab, it might actually have you list the whole thing out like I'm doing, or it might have you list out the missing pieces. Pay attention to the question that's asked, all right? So if you're not paying attention to the question that's asked, it's really easy to get things wrong if you're making assumptions on them. So just be careful. So what comes after my 6? And then? Okay, so this is the listing method. It's not particularly difficult. We can certainly do it, but imagine that this actually didn't stop at 22 and it stopped at like 122. That'd be really annoying, wouldn't it? That would be a terrible question to give you. It really would. And the listing method, while doable and not particularly difficult, would not be your choice. It just wouldn't. So we want to have another way to write that, and the set builder method actually works a little bit better for this one if the list goes on too long. So let's take a look at how we can write this if we're doing set builder notation. So again, it's the x in a bar. And we need to tell it that we are working with the numbers between 2 and 22. Now, you're welcome to use like 1 and 23 and do the less thans. You're welcome to do this. I'm going to erase this, so don't write it down right just yet. You're welcome to do that. I don't think for me that that's what I would do. I would be more likely to use the less than or equal to symbol because of the way that they're listed. But either one would be correct. Okay? So numbers between 2 and 22. What else? We needed to say that it's evens, right? That's a problem on this one. We don't want to just say whole numbers because that would include the odds as well. So we would need to say that x is even. And there's actually not a better way of doing set builder notation for this one. This is what we would do. Okay, any questions so far? All right. This one asks you to specifically do the set by the set builder notation. And it describes it as the set of all rational numbers. You'll notice it doesn't even have an option where it says, and use the listing method. Okay, so rational numbers, we're going to talk more about these a little bit later too again, but rational numbers include all your decimals that end, those are called terminating decimals, all your fractions. They don't include things like pi. They don't include like square root of 2. They include a lot of things. If you can imagine just taking the number 1.8, okay, but you're also going to have 1.81 and 1.82 and 1.83 and 1.87, and then you're going to have 1.8765. You couldn't list them. It's not possible. The listing method doesn't even work here at all. So set builder notation is the only option. It's x such that. And all we're going to do, and it's going to feel a little bit funny, and again, another one we're going to come back to in a minute, is we're going to write down that x is a rational number. And I know, again, you're looking at that and you're going, but that's kind of dumb. I mean, like, that's what it started out saying. Okay, I get that. We're going to have some notation later, and it'll be a little bit better. But this is one way of doing this, and it would be correct. Okay, so this is actually going to be a picture. So you've got a big old space on the side of your page like this, right? Do you see how I've got a big old rectangle drawn in here? You have better space to work with than I do. I'm going to do my best on my screen, but your paper's got more space. We're going to be drawing a picture. So the first thing I want to do is actually just go down this list here that's given and give you the notations that are used for these types of numbers. So that's my thing number one. Natural numbers. Natural numbers look like this. Okay, it's an N. It's got a double line on the left when you draw it. When you see it in printed form, it usually boldens the line on the left instead of double lining it. But even inside of like Microsoft Word, if you go into the tools, sometimes there's some double line left, on the left things, and you can do it that way too. So natural numbers is N. Whole numbers would be W. Same thing, double line on the left. And as much as you want to, and maybe you already did, integers is not I. Integers is Z with a double line in the middle. And it's Latin. Okay, so that's coming from the Latin word for integers. Rational numbers is also not R. Rational numbers is actually a Q. The reason rational numbers is a Q is it's actually for the word quotient. Quotient talks about division, and rational numbers are numbers that can be written as fractions in a division form. So we use Q. Real numbers is R. Irrational numbers is still not I. Irrational numbers does not have a singular lettered form. The way you see irrational numbers written is the letter R, real numbers, minus the rational numbers. In other words, if you take all of the numbers, everything, and then you remove the rational numbers, you are left with the irrational. And I'd like to draw you a picture, and we're going to first draw the picture, and then I'm going to actually talk about the details in the picture. So the first thing I want you to draw is a large rectangle. Okay, so yours is going to be better than mine because I don't have a lot of space. I want you to take that rectangle and split it into two pieces. There's really not a size that you're splitting it into. You're just splitting it into two pieces. I'm going to put mine right here. And I know it kind of looks like I'm overlapping that kind of green in the side, so maybe I'll just do it like this and enlarge it a little bit. Inside of the larger side, which mine is the left-hand side, I want you to draw in 3 embedded rectangles or squares. Okay, this is our picture that we're going to be working with. Okay, everybody good so far? Drawing a picture. All right, we're going to start in the very center of the picture, okay? The very center of this picture right here is the numbers that you first start working with children when you're counting with them. And the first number that a child learns is what number? 1. All right, so we used the number 0 before, but we usually do not start with children with the number 0. That's just not the way it works. We start with 1. So inside here in this little box in the middle, that yours is hopefully bigger than mine, are your natural numbers. These numbers are the ones you naturally start to count with. And sometimes they're also called counting numbers. So the numbers here, N, and I'm going to write them out up here because I don't have space inside of my picture. If you have space inside your picture, that's great. It's the numbers 1, 2, 3, and so on. Okay? All right, the next thing we do is that we broaden our universe, if you will, when we hit the number 0. Okay, so kids start with 1, 2, 3, 4, and then it's not too long afterwards that you can introduce the concept of having nothing, having 0. And so if you take that number and you include 0, you get the next box on the outside, which is the whole numbers. So the whole numbers includes our same natural numbers, the ones I don't have space to write, but it also includes the number 0. I have space now, so I'll write that one in there. And then there's some smart aleck on the bus that says something like, well, then what's 5 minus 7? And you don't have a number for that, right? So you have to broaden your idea of what numbers are one more time, and you get the negative numbers. So the negative numbers and the positive numbers included, both of them, make up what are called the integers. So that's this Z. So I'm going to put dot, dot, dot. It's -3, -2, -1, 0, 1, 2, and so forth. Okay, they're going to keep going. So we get the positives and the negative numbers. Those are our integers. After the integers, what we do is we do the division pieces. Okay, so integers and quotients are often taught backwards of that as you're learning numbers, which is fine. Negatives are usually coming after, numbers like 1/2. But inside of our boxes, this is what's next. So this is my quotients, my rational numbers Q. And this includes all of your numbers that have fractional form with whole numbers. You can be written as a fractional form. So it would include numbers like 0.5 because it can be written as 1 over 2. It also includes numbers like 1 over 3, which don't have a closed form in decimals, right? It's 0.3 repeating. So it includes your repeating decimals because they can be written this way. It also includes negatives. So all the negatives are included as well. So like negative 7 over 8, or something like that. All the positives and negatives are included there. And it includes everything else as well. So like the 5. Like a 5 is a natural number. It's in the very center of my picture. But it's also a whole number, and it's also an integer, and it's also a rational number because it can be written as 5 over 1. So everything's embedded because it's included in this broader picture of the numbers that we've built upon. The side over here is our real numbers minus our rational numbers. And the types of numbers that get included over here are ones that you can't write in a fraction form where you've got whole numbers. So you do get things like pi. If you've had an Algebra 2 or a college algebra course recently, the E would be included here. E is about 2.718. But it goes on just like pi does. You'd have all of your radicals that you don't have closed forms for, like square root of 2. Okay, so not all radicals, right? Square root of 4 would not be over here because square root of 4 has another form 2, and we would put it somewhere else. But square root of 2 can't be simplified in that way. It's an irrational number. So we've got all of our irrational numbers over here. Okay, I want to do one more thing here so I can go back and fill in my details. Flip over to the next page. I should probably change the order of these are. I just want you to do these symbols so we can fill in the note pieces that I missed. All right. Underneath symbols, after number 7, which we will come back and get, there are 2 symbols that we're going to see used in set builder notation quite frequently. These are our first 2 symbols after all the letters that I just showed you, right? And these symbols kind of look like an E, but they're sort of curved on the side. The curved part's necessary. You can't use the boxy E. If you try to in my math lab, it's going to fuss at you. It has another meaning. It has to do with scientific notation. You can't use the lowercase e. That's the number approximately 2.718. Okay, so this symbol itself is an element of. Now we talked about elements at the very beginning. Elements are just the things that are in some category. Okay. So this is the element of symbol. And anytime we put a slash through something, you just include the word not. So if we put a slash through that element symbol, it means it's not an element of. Okay, so flip back real quick to the very first page now, where I said we were going to come back to this one, very, very first notations. Set builder notation. Set builder notation is shorthand, is what it is. And you guys like shorthand. If you've ever texted LOL, THX, those are the 2 I text all the time. I know I'm old. BRB, there's some that you could say that are inappropriate. We won't do those. But you've used texting language where you shorthand things all the time, right? That's what set builder notation is it's shorthand mathematical notation. And so the form of this that's most helpful starts out the same, x such that x is less than 7. But instead of saying and writing out x is a whole number, what it does is it says x, and it uses that element symbol. It's an element of w. X is a whole number. It's just shorthand notation is all it is. All right? So let's do the same thing then for examples 1, 2, and 3 that we saw after this. Well, we can't do it for 2. We can do it for 1 and 3. For number 1, x such that. The less than part is all still the same. None of that changes. It's the part at the end that changes. Instead of writing out x is a whole number, we write out x is an element of w. Cool? And then the second one doesn't work. We don't have a notation for even. You could simply change the word is to the element if you wish, but that's not really all that helpful of a change, so I'm not going to write that one in. But this is the one that I wanted to show you. This is x such that, and we say x is an element of q. Rational numbers are q. So this is actually the shorthand notation that you would see used when we're doing the set builder notation for this. Okay, let's jump back to where we were after the picture. So we have our picture, and now we're here. All right, cardinal number. The cardinal number or cardinality of a set is just the number of items that are in it. So if I talked about the cardinality, the number of items that are, like people, like if I talked about the set being people that live in my house, like full-time live in my house right now, there's 6 of us. So the cardinality of people living in Dr. Hand's house is 6. Okay? If my kids were counting, they'd probably put the 2 cats, the dog, and the fish in there. And then we'd have a bigger number. Okay? But it just means the number of items that are in a set. And it uses the letter N. That's nice. N to remind you that it's number of. And then in parentheses next to it, it describes the set or gives the name for the set. Like if we had the name A, like it does down here on number 4 and 5, right? It describes the set by giving it the name A. Then what's going to happen down here is we're going to find N of A, the number of items in set A. Okay? So what we see used a lot of times, and what frustrates people a lot of times, is that there's shorthand used in math a lot. And we do it so we don't have to write as much, just like you do it in your phone. Okay, it's not any different. It's just that it's math lingo instead of it being texting lingo. All right? So when we see N of A, it's telling us to count the items that are in set A. So if you see number 4, how many items are in that set?
7.
It's 7. Notice there's no curly braces. It's just 7. It is a number of things that are there. Now on 5, it's a little bit less direct. Agreed? You've got a list of things. You either need to fill in however many things are on the list, right? Either by counting in your head, counting it on paper, writing them down, whatever it takes, or you need another method to find them. Let's just fill them in and count them out, because this one's pretty small. So if we were to count this out, right, we can go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. There's 10. I counted 10 of them. So this would be 10. Okay? Now, sometimes it's not the easiest way, so let me actually give you another option, because if this is said from 5 to 504, that's not a good example, 505, let's go with that. 5 to 505, you would not want it to go 5, 10, 50, all the way up to 505. That would be ridiculous. You'd need another way to do that, right? So how can you do that? Well, if you take a look, what you can actually do is you need to know what number comes before the list. So in this pattern, what number comes before 5? 0. Okay. So the way that you would do this is you would take the number at the end, 50. You need to subtract what comes before it. We don't want to subtract the 5 because then we're removing the 5 from the list, right? We need to remove the things that are before it in the list. Now, 0 is not very exciting, but that's the number that's showing up on this one. And then what we're going to do is we're going to divide it by how much it's skip counting by. This is skip counting by 5s, right? 5, 10, 15, 20. So if it were skip counting by 7s, 7, 14, 21, 28, you divide by 7. However much it's skip counting by is what you count, or what you do the division by. Because you don't get every value, you get every 5th number. That's why we're dividing by 5. So we would end up getting 50 divided by 5, and that gives us our 10. Okay, are we good? All right. Now, because we're talking about number of items in sets, there are 2 different types of sets that we can describe. One are finite, and the other is infinite. So a finite set is a set where the cardinal number is a particular whole number. Like I can actually write down 10. There's 10 items there. Something that is infinite is a set for which the number of elements is so large it cannot be measured by a counting number. So if you were imagining it, you might think of it as being the value infinity, right? Infinite sets, infinity. But infinity is not a number, it's a concept. It's a concept that says it can't be counted. That's what it is. Okay, so if we're taking a look at 6 and 7, and we're deciding if they're finite or infinite, you're just asking yourself, is there an actual number that I could count this out to be? It doesn't ask you what it is, right? It just says to decide if it can be counted, if you can count them up. Number 6, is it finite or infinite? It's finite. It's got a dot, dot, dot in between, but we could list them out if we needed to, or we could count them up, or we could do my little trick where I take the number before and subtract and divide. We could do any of those things. This is a finite set. How about 7? That is infinite. What triggers us to understand that this one is infinite? Yeah, that word greater is the tricky one, right? So greater means that it's not going to end. There's no stopping point. So if this had said less than, natural number less than, it'd be totally fine. What if it said that it's an integer less than? Well, we'd run into the same problem because integers go infinitely in the other direction, right? So it matters that it says greater than. That's very important in this particular one, but it also matters that it's natural numbers specifically. So you have to consider the set that you're looking at and the description of it both. Okay, we already did the symbols, element and not an element. What we're going to do now is we're going to fill these blanks in with the proper symbol. So it says to fill in the blanks with either the element or not element symbol to make the statement true. So this tells you you have an element 7. Is 7 an element of the set that's being described on the right? Yes, it is one of them there, right? So we're going to put an element symbol here. Number 9 looks similar, but there is a difference between 9 and 8. It's the curly braces. Do you see that? Those curly braces tell you that this thing on the left-hand side, it isn't an element at all. It's a set. It's a lonely set. It's only got the number 3 in it, but it's a set. So I can't put an element symbol in between here because it's not an element to begin with. It's a set to begin with. So this one actually fails. It doesn't fail because there's no 3 on the right. It could fail that way, like that'd be an option, but that's not why it's failing. It's failing because of those braces. Those braces around it make it a different kind of object. They make it a set, they don't make it an element. All right, we've got just a little bit left, so we're going to finish this up real quick. 2 sets are equal if every element in one of them is an element in the other one. So every element of A is an element of B. Every element of B is an element of A. That's what makes sets equal. So if I were describing the people that lived in my home and my husband were describing the people that lived in his home, because we live in the same home, those sets are equal. Right? So those are equal sets. 10 and 11 are really good examples of things that show up in my math lab. They like to give you things where you decide if something's true or false. I will warn you that what happens if you get it wrong is they usually just scrap the question and start over, so it's not like it's a 50-50 and I'm just going to get it right on the second try. It's not usually how it works. Because obviously if you say true and it marks you wrong, you're going to say false and you're going to get it right, but you may still not know anything about it, right? That doesn't really help. So most of the time they scrap them and give you a new question when they're asking you these kinds. So this one is asking us if the statements are true or false. So the first one, number 10, says 6 is an element of -2, 5, 8, 9. True or false? That's false. Another way that they might ask this question is they might ask you to fill in the blank with an appropriate symbol like the last questions that we looked at, right? Could do that. And 11 says x, such that x is a natural number less than 3. That's the description it's giving you on the left. And on the right, it gives you the listing method of the numbers 1 and 2. It has an equals between. Are these sets equal? They are. And it's important to remember what natural numbers are. If it said whole numbers, then the answer would be no. right? But this says natural numbers. Natural numbers are the numbers 1, 2, 3, 4, and so on. And it says less than 3, so it won't include 3. So this one is a true statement.